Hey guys, today we're going to be looking at different properties that we use when we're being mathematicians. So here we have Monique and Elise, and they both have bags with equally sized stars and hearts as shown below. So we have Monique's collection, and then on the other side we have Elise's collection. And we want to use these images to represent the statements below. So Monique has blank bags with blank stars and hearts in each bag. So right off the bat, I see that she has 3 bags. And in each bag, there are 4 stars. So we have 1, 2, 3, 4 stars. And 2 hearts in each bag. So I can write that mathematically, saying she has 3 groups of 4 stars and 2 hearts. Elise has only 2 bags, but in each of her bags there's 1, 2, 3, 4, 5, 6 stars and 3 hearts in each bag. So mathematically we can say 2 groups or 2 bags of 6 stars and 3 hearts. But if we wanted to know total, we could count individually. But if I know she has 3 bags, each of them have 4 stars, that is 12 stars total, because 3 groups of the 4 stars. But she's also going to have 3 groups of the 2 hearts, so that's 6 hearts total. Well, Elise has 2 bags of 6 stars each, so 12 stars total. And then 2 bags of 3 hearts each, or 6 hearts total. So they have the same amount of hearts and stars. It's just a matter of how they're being represented and in how many different bags. And if you notice, when we're talking about grouping and 3 bags of 4 stars or 3 bags of 2 hearts, to find the simplified number of how many stars and hearts they have, we use something called the distributive property and said, okay, so 3 groups of that 4 stars, 3 times 4 give me 12. And 3 groups of the 2 hearts, well, 3 times 2 is 6. So we can apply that same thinking to something, say, 4 groups of 2x minus 3. Well, I would have 4 groups of the 2x, like 4 bags of 2x's in each bag, which gives me 8x. But then I would also have 4 groups of the 3 negatives, which is negative 12. So this thinking can be applied with images, but also with our expressions that we've been using. And so speaking of some expressions, we want to look a little bit further and see some other ones that we've been using. So right now we have 4 groups of 16 plus 7 plus 6. And so notice the next blank that they have, we have 4 times blank and plus 4 times blank. We can use our distributive property right here. So this gives me 4 times 16 plus 4 times 7 plus 6. The first property we just used, that's our distributive. And I know 4 times 16 gives me 64. This blank right here is for 4 times 7, which is 28. But notice from here to here, they're switching something. So we had 6 in the back, and now we have it in the front. So I can put 28 in the back. 64 plus 28 plus 6 is equivalent to 64 plus 6 plus 28, because it does not matter what order we add in. 2 plus 4 is the same as 4 plus 2. So then from here to the last row, I see that they composed 64 and 6 to make 70. So we still add on our 28. And then 70 and 28 will combine to make 98. So some really big properties that we use throughout this is we use the distributive property when we distributed the 4 to the 16 and to the 7. But then we also saw that it did not matter what order we added in, right? Because 28 plus 6 is the same as 6 plus 28. We call that the commutative property. which you really don't need to know the actual name, just how it works. Right, so I'm just going to summarize that as saying, doesn't matter what order we add in. All right, and let's look at one more. So here we have 27 combined with 12 negatives. And I see that the next row, my 12 negatives are still intact, but 27 has now been decomposed into 15 with something extra. Well, 27 decomposes into 15 and 12. And so then we look at our next row, because I have not changed anything yet. I see that where there were parentheses around 15 and 12, now there's parentheses around a blank, which I'm assuming is still my positive 12, and the negative 12. This is called our associative property. We're just grouping different things, putting parentheses around it. And I see that 12 and my negative 12, I know that that will make 0. And so 15 plus 0 will be 15. So big property that we used is we decomposed. We decomposed our numbers to be able to use this property. And then we used additive inverse. What that means is any number plus its opposite gives us a value of 0. So if I have 3, a negative 3 will make 0. Negative 15 and a positive 15 will make 0. Negative 2x and a positive 2x will make 0. It's just this idea that anything and its opposite will make 0. And so we use that property a lot when we solve equations, but also when you look how we simplified this expression. By decomposing 27 into 15 and 12, I knew that my positive 12 and my negative 12 would make that 0 pair. So I was just left over with the 15. It's just another way of performing our arithmetic in a flexible way that sometimes is easier to do in our brains. But all right, thank you very much.